All right.
If you notice that we've derived the 4K formulas, and there's 5 up here, and you can also jot down my handwriting, mostly. This is the 5th one right here that I don't include. And some textbooks do, some textbooks don't. I don't feel like it offers a whole lot that the others do. That's why I tend to ignore it. All right, any questions? Okay. Let's just run through a problem and then put a nail in the coffin of chapter 2.
Is that H or it before accelerate?
It. All right, so here's a nice sampling of, you set up the problem, you have given 3 knowns, or, yeah, there are 3 knowns, and then there's just a series of questions after it. The only difference between this and a test level problem, it might be nothing, or I might just give you a different 3 pieces of information. some of which could be potentially implied, depending upon which direction it's going. This, I assumed horizontal motion, but I'm not worried about gravitational pulls right now. And it's traveling parallel to the gravitational pull. In other words, it's traveling horizontally. And since I tend not to give you that, the fifth equation that I mentioned earlier, I'm just going to erase it and keep the others. So, in solving a one-dimensional constant acceleration problem, what's the first step?
Repeat that?
When solving a one-dimensional constant acceleration problem, what is the first step?
Find the constant.
Moran, you were about to say?
Well, I was just gonna say, I would figure out what like all the variables are that's given to us.
Okay. And I know that, oh, there it is. All right, so we have our big five: displacement, initial velocity, final velocity, acceleration, and time. What do we know?
You know, the initial velocity is -14 meters per second.
All right. What else?
You know that the final velocity is positive 25 meters per second. You know the acceleration is 6 meters per second.
Other people can play too. It's okay. All right. So first question is how much time elapsed? And again, scattershot method is you can plug into every equation and see where you got a single unknown, or just think through it, which equation is going to be the one to use.
The first one,
Why?
because you have the initial and final velocity and the acceleration. And the only other variable in that equation is time, and we're looking for time.
Sounds good. All right, so we have VF equals VI plus AT. So we're left with 25 equals -14 plus 6t. That's the math problem right there. And so the 39 divided by 6. Now notice if you do it properly, you'll end up with a positive time, which is what's to be expected. If we had a negative time, then there's a good chance that we did something wrong. 625.
Yeah.
All right, so we know time now. Now, over the course of the 6.5 seconds, what is the displacement? How do we solve that?
The second equation.
Okay, that works. So delta S is equal to VI plus VF. 2 times time. So I got -14 plus 25 divided by 2. Oh, that's a subscript F there. Times 6.5. Somebody wondering that? No.
Maybe backwards.
Say it again.
35.75. Meters?
Yes, meter. All right, so 35.75 meters. All right, so the first two problems are taken care of here. How do we find average acceleration? We have two ways of doing it. One way always works, the other way works in this case.
You want to find the average velocity? Are you on the third question?
Yes.
Okay.
What is the average velocity? And how do you find it?
Don't you just add the two velocities and find what's good?
When does that work?
If the acceleration is constant,
Yep.
like this one it is.
Yes, it is, all right. So there's your average velocity right there. So my average velocity so I've got negative 14 plus 25 divided by 2, which is 5.5 meters per second. What is the other way that always works? Assuming you have the information you need, but what's the formula for average velocity that is always true?
Your displacement over your change of time.
Yes. Which in essence is where we get this equation from. All right, so we have our average velocity. All right, so now questions up to here. So first off, do we know that this object stopped?
No.
Why not? That'd probably be a difficult one to answer. Why do you think it did?
Because it changes direction.
Yes.
It has to go through zero.
Therefore, you're saying it did stop?
Yeah.
We're wrong?
The velocity is
You were saying it
zero.
didn't stop.
Oh, I thought you meant like, did it stop at the end?
No, it just, at some point during the path that it'd have to stop. And yes, Ava's reasoning is right. So we're trying to figure out at what point, well, actually, the initial velocity doesn't change, acceleration stays the same. What changes for this problem?
The speed.
Which one? The question is at what time did it stop? So this one probably is going to change. How do we find the time it stopped?
Do you,
4 1/6. Hold on, I'm thinking out loud.
Okay.
yeah, plug in final velocity is zero.
Yeah, you're trying to figure out what point is the velocity zero in whatever
It's
distance
after
of time
4
you go.
4 1/6 seconds.
You said between 4 and 6 seconds or 4 and 6 seconds?
After 4 1/6 seconds.
4 and a sixth.
Yeah, because 25 is 6 times 4.6.
Okay. So, pick it up where Robin was. In essence, we're using this equation right here. Except now, it's 0 is equal to 25, sorry, try that one again.
Negative 14.
Negative 14 plus 6t So T is gonna be 14.6, I think you did 25 divided by 6. Which puts it at 2 1/3 seconds.
Well, I was wrong, damn.
I think your process rate just made one. The moral of the story is show your work. At what, I'm gonna skip that next question for now, we're gonna come back to it. So, define the distance that it traveled. So I know it turned around. It traveled for 2 1/3 seconds in the negative direction, then it stopped very briefly, not permanently, and started moving in the positive direction until for the remaining amount of time. Just drawing up, so let's say it started here, goes in the negative direction, stops, turns around. I know that this is 2.3 repeating seconds, and this is this part right here, 6.5 minus 2.3 repeating seconds. So how do we find the distance it traveled?
We multiply the seconds passed by the displacement? No, wait, that's wrong. Distance traveled is distance forward.
In terms of what we know, we've already figured out the distance from here to here. That is 35.75 meters.
Can't you just use, the second equation, but instead of the time being 6.5 seconds, we use 2.3 seconds to figure out the distance?
Are you using this equation here?
Mhm.
I guess the second equation there too. Yeah, that works. So we take this equation here in the same color, there we go. And so how far does it go to the left? It's going to be 0 plus negative 14 over 2 times 2.3 repeating. So 7/3 times 7, 49/3. Third.
16.
What'd you get? 16 and a third. So we now know that from here to here, 16 and a third meters. So what was the distance traveled? Not without a rip in the space-time continuum. Your thinking's almost there. You forgot something.
I know. 68.35.
What did you do wrong the first time?
I forgot to add, another 16.3 meters because you go back and forth.
Yes. So I know it goes 16.3 meters in the negative direction. I guess I established that as positive. He has to get back to the start because the displacement, the final displacement, 35.75 meters, is relative to his starting point. So we have to add the 16.3 twice. Once to the stopping point, once to the starting point, and then to the final point. End of problem point. So if you add 16.3 repeating plus 16.3 repeating plus 35.75, you get roughly 80 something. I forgot what you said at this point.
68.35.
One more time?
68.35.
68.35 meters. Now you might get a slight difference depending upon how you round it. So that's the distance traveled. And so how do we find average speed?
Isn't it just the same as velocity without the direction?
Only if it doesn't change direction can you get away with that. The number of people who have missed that. So average velocity, how do you find average velocity? Not the adding the initial and final, the one that always works. How do you find average velocity?
Initial velocity plus final velocity divided by 2.
The other one, the one that always works.
No.
That only works if acceleration is constant.
Changing displacement over changing time.
Say it again.
Changing displacement over changing time.
I'm gonna if you had written it down, I assume you would have written it down correctly, but the wording was off. Let's just nitpick that just a little bit. It's not changing displacement over time, changing time.
It's rate or position.
Say it again.
Rate or position.
Did you say weight?
Yeah, I don't know which one.
She's saying rate or position.
Yeah.
Right. Oh, position. It's changing position over changing time. Or you would just say displacement over changing time.
Okay.
Or if you felt like it, displacement over time also works. All right, so velocity is change in position over time, or displacement over time. What would average speed be?
In this equation specifically?
In general, always. If you ever need to find average speed, how would you find it?
Distance over time.
Yeah, it's just the scalar analog, it's distance over time. We just found distance. Now you divide by time, which we know is 6.5 seconds. So 68.35 meters over 6.5 seconds. And you get